Solving a rational equation. Remember, a rational equation will have fractions in it, and we need to be very careful to check for extraneous solutions at the end. This rational equation is 4x plus 3 over x plus 1 plus 2 over x equals 1 over x squared plus x. To get rid of the fractions, we need to multiply everything by the least common denominator, the LCD. To help us choose the LCD, it would help to see all of the denominators in their factored forms. So this fraction at the end, 1 over x squared plus x, that denominator can be factored into x times x plus 1. Our choice for LCD needs to be a multiple of each of these denominators. So we're going to choose x times x plus 1. We're going to take this LCD and multiply it in every term of our equation. Since we're multiplying by fractions, I would recommend that you write your LCD as a fraction, x times x plus 1 divided by 1. This step of the problem looks kind of long and messy, but if we've chosen the common denominator correctly, then our fractions should cancel. For instance, this x plus 1 cancels with an x plus 1 on top. In the next term, we see we have x's that cancel. And on the other side of the equation, we have x's that cancel and our x plus 1's cancel. Let's look at what we have left. This creates the equation x times 4x plus 3 plus x plus 1 times 2 equals 1. Notice the parentheses, these are very important. Okay, we've gotten rid of all the fractions, and what we have as a result is a quadratic equation. It doesn't look quadratic right now, but let's go ahead and distribute to get rid of these parentheses. We need to distribute the x, and we're going to distribute this too. That gives us 4x squared plus 3x plus 2x plus 2 equals 1. Since this is a quadratic equation, we probably want to get this in standard form. So let's combine like terms. 3x plus 2x equals 5x. Then to set this equal to 0, I'm going to subtract 1 from both sides. Now we have 4x squared plus 5x plus 1 equals 0. Let's try solving this by factoring. If that does not work, we could always try the quadratic formula. But factoring is pretty fast when it works. Let's go ahead and set up our parentheses. We need two numbers that multiply together to be 4x squared in the front, two numbers that multiply together to be 1 in the back. So let's try this. Always check your factoring before we go any further. By foiling this out, I see it does factor correctly. Next, we're going to set each of these factors equal to 0. We've got 4x plus 1 equals 0. To solve for x, I need to subtract 1 from both sides and divide by 4. We get a possible solution of x equals negative 1/4. Our other equation was x plus 1 equals 0. To get x by itself, we just need to subtract 1 from both sides. This gives me a possible solution of x equals negative 1. Now I'm calling these possible solutions because they may or may not make my equation true. We need to check for extraneous solutions. Okay, so we're going to check going back to our original equation, and let's check the solution x equals negative 1 first. So in our original equation, everywhere that we see an x, we're going to put a negative 1 in its place. Now this is going to give me a problem here and here in the denominators of these two fractions. In that denominator, a negative plus 1 gives me a 0. And you'll remember from previous math classes, you cannot divide by 0. So it turns out that x equals negative 1 is an extraneous solution because it does not make the equation true, it makes it undefined because we have that 0 in the denominator. So negative 1 was an extraneous solution. We have one more solution to check, so let's check x equals negative 1/4. Back to the original equation, everywhere I see an x, I'm going to put negative 1/4 in its place. And just simplify bit by bit. On top of this first fraction, 4 times negative 1/4 makes a negative 1. In the bottom of that same fraction, negative 1/4 plus 1 makes 3/4. Also at that last fraction, we have a 3/4. Okay, negative 1 plus 3 in the first fraction gives us a 2. Multiplying fractions in the last fraction gives me negative 3 over 16 in the denominator. Seeing fractions within fractions looks really messy. This looks horrible. So instead of dividing by 3/4, let's multiply by its reciprocal 4/3. Similar thing for each fraction. Instead of dividing by negative 1/4, let's multiply by its reciprocal. Okay, then multiplying these fractions and numbers together gives us 8 over 3 plus negative 8 equals negative 16 over 3. We're very close to seeing if this is a solution. We need a common denominator though. Our common denominator would be 3, so let's rewrite negative 8 as negative 24 over 3. And then finally we get negative 16 over 3 equals negative 16 over 3. It's a true statement. So x equals negative 1/4 truly is a solution. It makes my equation true.